as gas turbine manufacturers are looking for continuous operations or stable combustions, satisfactory emission level, minimum pressure loss, and durability or life. Hence, the advanced combustor might include all of these criteria. The next generation gas turbines will operate at higher pressure ratio and hotter turbine inlet temperatures conditions that will tend to increase nitrogen oxide emissions to conform the future air quality requirement. Lower emitting combustion technology will be required. Some of new combustion system will be introduced. First is trapped vortex combustions, or TVC. The trapped vortex combustor may be considered as a promising technology for both pollutant emissions and pressure drop reductions. TVC is based on mixing hot combustion product and reactant at a high rate by cavity stabilization concept. These technologies, it is possible to burn a valley of fuels with medium and low calorific values. It is possible to operate at high excess air premix regimes, given the ability to support high-speed injections, which avoid flashback. NOx emissions reach extremely low levels without dilutions or post-combustion treatments. Produce the extensions of the flammability limits and improves flame stability. Next is the continuous stage air combustions. The concept uses continuously staged air and internal recirculations within the combustion chambers to obtain a stable combustion with low NOx and carbon monoxide emissions. The burners have the advantage of operating in full diffusion mode or in a partially premix mode. The heat is released more uniformly throughout the combustion chambers. Also, the recirculated gas absorbed some of the heat of combustion. Is capable to work stable at a whole combustor walls as well as high air ratio. The third one is mild combustions. Heat recirculating combustions was clearly described by Weinberg as a concept for improving the thermal efficiency. In flameless combustions, the oxidation of fuel occurs with a very limited oxygen supply at a very high temperatures. Spontaneous ignition occurs and progress with no visible or audible signs of the flame. Usually associated with burning, the chemical reaction zone is quite diffuse, and this leads to almost uniform heat release and smooth temperature profile. All these factors could result in a much more efficient process as well as reducing emissions. The last one is the full electric combustion chamber. Plasma propulsion engines, which are currently used in space missions. It uses the kinetic energy of plasma itself to generate the thrust required by the spacecraft. The idea instead is of using the plasma and its great heat to replace the heat generated by the combustion of fuel. And this is the chart of fuel electric combustion chamber. The primary flow comes to the plasma zone and receive the heat and go through the mixing zone before pass through the turbine blade. This is a clean energy and the technologies, no NOx or other emissions. These are the ideas of the future design. Although the turbine inlet temperature is the major factor determining the overall efficiency of gas turbine, but high inlet temperatures will result in larger NOx emissions. So the essential requirement of the new combustor design is a trade-off between low NOx and improved efficiency. And this is the end of the video.